And we're live. Good morning, good afternoon. This is a new virtual IoT session, a slightly different time than what we typically do. The reason is, well, you will figure that out very quickly. Today, we're going to talk about the Open IoT Challenge. You may have heard about the Open IoT Challenge. It was actually the third edition that we conducted just a few months ago, together with the Eclipse IoT working group, as well as our sponsors, Beach Reactive, Eurotech, Red Hat, Bosch. They've been very helpful in putting together a super nice prize pool for our participants. And what was the goal? What was the challenge? Well, I think it was actually easy, and fairly open. I think you'll realize that later on today with our three winners. What we wanted is for people to build innovative solutions using open source software for IoT. And today you'll have the proof that, well, open source actually helps build innovative solutions for IoT. So the challenge ended a few weeks ago, actually, and our three winners are from all over the globe, which is why we needed a slightly different time. We have people from France, from Canada, and from India in no particular order. I mean, our winning team is from France. Second is Siva from India, and number three is Tom from Canada. And without further ado, I will let Tom switch to his presentation. Before that, I want to remind you guys that we love to make those sessions interactive. So I'm sure Tom, Siva, and Sebastian, and myself and Roxanne was also on the webinar. We'd all love to hear your questions and to answer questions, comments you may have. So the easiest path is probably the chat on YouTube. This basically just works. You can also engage on Twitter, and actually our participants some of them are actually active on Twitter as well. But if you tweet using the virtual IoT hashtag, we'll make sure to monitor that for you. And yeah, that's what I had for you guys as an intro. And now we are going to spend some time with our three winners, going from number 3 to 2 to 1, and starting with Tom from Canada, as I said, and the project is called Eneristics. Tom, welcome.
Thank you, Benjamin. Okay, I'm just going to, I'm Tom Maratz, and I'm the project lead for the residential home diagnostic system. I'm just going to start sharing my screen at this time. Hopefully you can see that. Yep. So I'm going to be presenting a brief overview of our project. I'm not going to go into too much detail for the sake of time, but I'd encourage you all to check out our blog. All the project details is there. My contact information is on the screen here, and if you want to contact me later on, I would be pleased to answer any questions, and I'd also encourage any questions that you have along the way. You can please feel free to answer them. So, okay, so my agenda today is to essentially go through the mission and goals of our project, basically what we plan to do, what our motivation was for undertaking the project. I want to talk a little bit about our value network, for whom we were creating the value for, who we believe our target customers are and end users are, and go into a little bit on our strategy, basically our approach to how we were going to deliver against the project, what resources we were going to use to essentially accomplish our mission. I'll take you through a live demo of our solution, and then we'll talk a little bit about next steps and basically where we see the project going from here. So in terms of a little bit of background, I'm in the home energy audit space, energy efficiency improvement business, and I'm very interested in the IoT space, and I have interest also in environmental issues. And I've been thinking about a way to help reduce carbon output, greenhouse gases, using technology. And the bottom line is that we all produce too much carbon, according to the statistics, and there's simple things that I think we can do to help fix the problem. And so when the Open IoT Challenge came along, we came up with the idea of the residential home diagnostic system. And really, I think our mission is to help reduce the carbon footprint using open source technology of our homes. And the idea here was really to create a smart energy IoT solution for performing home diagnostics. And the idea is essentially a do-it-yourself energy audit system using IoT methods and sensors. So we set out to reproduce the key metrics of a professional energy audit. And today, really, that's about the only way that you can really figure out what's going on in your homes in terms of energy use, is to bring in a professional. So the idea here was to allow homeowners or service organizations to basically peer into the energy use of a home and to do self-diagnostics and optimize that consumption. And we picked heating and cooling because heating and cooling typically accounts for about half the energy use in a home, and it's the largest expense. And so the idea is that if we can understand how much energy we use for heating and cooling, we can certainly reduce that through observation, and then of course reduce the carbon output of our homes. And so our targets are essentially who we're doing this for is homeowners, giving them the ability to self-diagnose energy consumption and thereby lower their carbon emission output. We also see value for service organizations like heating, ventilation, air conditioning companies, and energy audits, where they can, with the system, peer into a residence and help provide better care, customer care for that environment, and essentially reduce truck rolls, which is also good for an environment because they can diagnose over the internet using the cloud as a means to view the data. Then that's going to improve the performance and customer care. We also see a value for government agencies, where we give them also the ability to give them essentially visibility into residential carbon output so that they can judge and audit the value of their energy efficiency programs. In terms of our strategy, we had a development team of about, we had 3 people on the team. We had a little bit of product management, some software skills, some building science, and a little bit of electronics. In terms of the hardware, we based the system off a Raspberry Pi 2. We were using Texas Instruments sensor tags, 2650s, and basically it's kind of 9 sensors in one. And we used an NXP microcontroller to house our Lesion, not our Lesion server, but our Wakama client for doing device management. At the gateway level, software, we used Eclipse Cur as the gateway. For device management, we used Eclipse Lesion and Wakama. And database, we used MongoDB, and all those are, of course, pretty much open source technologies, are certainly open. In terms of protocols, we used MQTT it's a pub subsystem. It's a lightweight messaging protocol, and that provided the communications between the IoT gateway and the cloud service. We used lightweight M2M between as the connection between our Lesion server and Wakama endpoints. And we used BLE between the sensors and the Kura gateway, and then of course a little bit of Wi-Fi in there as well. In terms of services, we used on the front end Amazon Web Services. We used their IoT gateway component to receive the MQTT traffic. We housed our data in the DynamoDB, and then we used their API gateway to give us a REST interface, which then we connected to using Freeboard.io, which is again an open source dashboard service. In terms of our architecture, essentially the system is based on a Raspberry Pi 2, and the heart of the system really is the Kura gateway. Its primary job is to connect multiple TI sensor tags via BLE and packetize the sensor data into a JSON format, and then create an MQTT data stream back to the AWS for cloud storage. Kura's secondary responsibility is to push a copy of the sensor data in JSON format over to a Mongo database. We found it necessary to do data cleansing and processing of the raw sensor data before forwarding it to the cloud. Basically, it was easier and more cost-effective to process data locally versus trying to do it in the cloud. And of course, our front-end application, as I mentioned earlier, is freeboard, and it's serviced through the REST API from Amazon. I'm going to switch over now to our brief view of the product itself. I'll give you an idea of the dashboard. So what you're looking at here is the freeboard application running, and this is a visual of all the sensor data that we're capturing. And again, the idea was, the goal was to be able to reproduce the key metrics of an energy audit. And the way we did that is the keys really were to be able to capture the internal environmental conditions and the external environmental conditions, and then use some building physics formulas to make some calculations. And then the goal was to be able to see if we could produce the same metrics as a energy audit, and we were able to do that. So essentially, the first thing we were able to do is reproduce the load profile of my home. And this is something that an energy auditor would come in to do a load calculation. And then this curve here, or this line, basically plots how much energy you need to heat and cool your home. And so using our formulas, we were able to reproduce that curve, and therefore we were able to make some further calculations. And so what we've got here is environmental data coming in from Environment Canada, and then we've got 4 sensors deployed throughout my home, and then we use formulas to essentially calculate how much BTUs my home is burning, and essentially the carbon output of my home, which is coming in at about 12.5 metric tons for my heating at this time. And then we're able to do some real-time calculations, so we can essentially do the same thing of calculating how many BTUs we're burning per hour in the carbon on a real-time basis. We're also able to calculate the air infiltration rate of my home, another key metric that's used by energy auditors to determine how energy efficient your home is. We're also tracking over here. Basically, it's a thermostat variation. It tracks how much temperature is swinging in the home. Eventually, it should be pretty tight. If it's too much of a swing, then your thermostat, of course, which is the control system of your home, isn't functioning properly, and this would identify that. And we're also able to pull in some humidity metrics to basically assess the comfortability of the home. And then we provided a little bit dashboard here, which has come in pretty handy a lot. This essentially just tells me if my data is coming in and it's being reported correctly. I find that the TI sensor tags are pretty hungry on the battery use, so these metrics here help me to keep up with replacing the batteries in the system. So essentially, that's the demo of the system itself, and I'll just switch quickly over to the final slide. Okay. So, okay, my last slide is essentially next steps. From here, what we want to do is validate and verify our results with government agencies to ensure that the data that we're producing is valid. And then on the technology side, we see ourselves doing a little bit more work with sensor efficiency. It says, as I mentioned earlier, the sensor tags that we're using right now are not exactly efficient. We'd like to find something that's a little bit more battery friendly. We want to do a little bit more on the historical reporting. So right now we have a live dashboard. We want to be able to allow the end user to basically look at history information. We want to go a little bit better UI. We want to tighten up our integration with our HVAC system, and we want to find a commercial cloud solution that's cost effective. In terms of use case, we see applications for smart cities, the smart grid, smart energy. Basically, it's just giving visibility into energy use, and then applying that data for whether it's for renewables or for better just understanding what your energy use is, or for lowering carbon output. We see applications for the HVAC industry to be able to provide them better service to their customers and basically reduce truck rolls. And education, I think, is a big one. We want to be able to provide real-time information for homeowners that you can use to better understand and learn about the impact of behavioral choices as it relates to heating and cooling. Presently, right now, the only way to do that is to send in an energy auditor, and so we're hoping the RDH system can be mass deployed, and then allowing people to do it themselves, and then they become the experts. And if they need to call in the experts, they essentially have the means to, because everybody can see the data in the cloud. So essentially, that's my system. I apologize, I went over a little bit of time, but I hope you enjoyed the presentation. And if you have any questions, my contact information is here. And thank you for listening.
Thanks very much, Tom. I actually have one quick question. Well, I actually have two, but I would like also to make sure that people ask questions if they have any. My first question, it's not meant to be a tricky question, although I realize it might be. How about what's your take on security? Like, especially like if you're building solutions and systems that tap into HVAC systems, etc. Have you already started exploring how to make the whole end-to-end solution secure, or is it still TBD, or kind of in between?
Security, obviously, yes, as you mentioned, is a big concern. We haven't really investigated that, but we'll be looking at that as definitely as a big priority. Okay,
great. So yeah, as a reminder, if anyone has any questions for Tom or for our other challengers, please use the chat on YouTube, or you can also tweet using the Virtual IoT hashtag. My second question, but I think it might make sense to actually keep it until the very end, and maybe in the meantime you can think about it. I was wondering whether you plan on investigating how machine learning, deep learning, AI, whatever buzzword you want to use there, could help, like taking into account the weather to do some calculation, predictions, etc. And I think this will actually be something that, to some extent, Sebastian will be covering, the topic of trying to figure out information within the information, like you collect all the sensor data and maybe you can find patterns, etc. But yeah, I would be interested in hearing how it would work for RHDS. Maybe we can talk about that at the end, if you don't mind, Tom, right? Do I have any other questions for Tom on YouTube or on Twitter? I don't think so, but please, again, as a reminder, please send any questions our way. Our next presenter is from is the leader of the team that created krishi-loT. Well, actually, there's a question from Jörg. How about we take your question at the end? But thanks for that, Jörg. Siva, are you around for talking about krishi-loT? I see you're on mute, so if you don't mind unmuting yourself, then we'll be happy to hear about what you've built. And there you go.
Yes, can you hear me?
Absolutely, welcome. So you were number 2 in the challenge, and I think, and correct me if I'm wrong, but it's not only you, right? It was a team who work on krishi-loT, just like for all the other projects, actually. Yeah, you've built something really cool around agriculture. So why don't you spend the next 10 minutes or so telling us about what you've built?
Yeah, sure. Yeah. First of all, thanks for the opportunity. And again, thanks for setting up the stage to share our experience so that we can share our experience and, spread the word, what we're doing. Okay. Again, thanks to Tom for the great presentation on RHDS. I liked it. So, okay, let me get started. As you know, we presented this krishi-loT. Again, let me start with the word, the krishi itself. The krishi is originated from in fact, it took it from Sanskrit language, and it stands for agriculture. So that's the word behind choosing this krishi-loT as the title of our project. So we presented this krishi-loT, which is like a comprehensive open source IoT solution, which will help farmers so that they can execute their day-to-day operations in a smarter and efficient way. So that's the kind of the aim of the project that we thought. So at the bottom you can see my contact details, and feel free to reach out to me if you have any questions going forward. Also, in fact, you can drop you can stop my presentation in between if you have any further questions. Feel free to so that it can be interactive discussion. Okay, I'm going to next slide. Going to the next slide. So how it all started is we need to have a cause, I believe. Some Yeah, as the title of the presentation itself is saying, what should it take to be a Open IoT challenge winner, right? So I really feel it. There should be a cause, and of course, not just the cause. There should be fun around it, and of course, the challenge. It should be the challenging work, and also thanks to Open IoT challenge organizers, because of the timelines that you guys have put in, that helps us really moving forward in the right direction, and keep us in reality rather than really thinking big and finally ending up doing nothing. Instead of that, it is really good to have some kind of bounded timelines so that we can have a bounded outcome, just like krishi-loT. So these open source technologies kind of really cool, and it helps realizing the IoT solutions make very quicker. So I do not need to talk about Eclipse IoT. As we all know, there is too much of, in fact, there are about 26 or 27 active IoT projects going on, starting from the devices layer, gateway layer, cloud platforms, so on and so forth. Who doesn't know Raspberry Pi here? I am pretty sure everybody is. It is kind of a de facto standard for IoT introduction on the devices layer for Raspberry Pi. So there is another cool chip that I come across, ESP8266, to do some kind of a low-end computing. So this is a pretty cheap device, comes around $4, I guess, with a Wi-Fi connection, and it does have some microcontroller as well. So we also wanted to, as you know, all these IoT devices doesn't have a head, in the sense it doesn't have a console to interact with it, or it doesn't have usually sometimes it doesn't even have a digital display. You do not know what is going on with the device. So the ideal interface is the mobile app. So Ionic is another open source hybrid mobile app framework, SDK framework, which provides which helps in building cross platform applications. That means you can use our web languages like JavaScript, AngularJS, the typical JavaScript frameworks, and build mobile apps for Android and iOS. So that's the cool part of it. Okay, this is about the motivation. Just to sum it up, there is a cause, and there is a fun, and of course the challenge. So these are the three combinations that kept us going. So with that, let me just give a brief introduction on why krishi-loT and what are the challenges and what does it offer. So we, just like I mentioned in the earlier slide, we just want to make the life of a farmer better. So we started off, what are the activities that a typical farmer do? So of course, he has to do the irrigation. He has to provide enough water to the crop. And the next thing is he has to monitor, he needs to monitor the crop day in and day out. The next, of course, based on for example, if there are diseases, he needs to take care of and protect the crop. The next thing is he also needs to play a role of weather forecaster. In the sense, he needs to kind of predict the weather and take some certain decisions. So with a lot of machine learning and intelligence coming from the other world, can we share this weather forecast information through this krishi-loT to the farmer? Is another, is the kind of thought process that has gone through. So on the other hand, coming to the challenges part of it, again, this is kind of envisioned in the context of India. And according to one of the fact books, about 47 or close to 50% of the Indian population rely on the farming. So that means it is a pretty good number. So the other biggest challenge here is availability of electricity to this farming. So yeah, in fact, in some situations, there are about only 7 hours per day electricity is provided to this agriculture industry in India. So in that situation, for example, with the IoT in place, how can we help the farmer in switching on the motor for just to pump the irrigation, just to provide the irrigation to the farming. At least if we can provide an interface, mobile interface. Of course, in the IoT world right now, it is pretty cool that one can trigger a relay or switch on, switch off devices remotely, right? One can do that. Many applications are there. People are building. So we thought, why can't we provide and tailor it to the agricultural application and provide an interface, and kind of solve this electricity issue. The next thing is the network connectivity. Right now, you see, I'm not sharing my video because the network is bandwidth is not good here right now, at least the connection that I have. So think about the situation in the agricultural land. Of course, we'll not definitely will not be having the broadband connection. So it will be GSM based connectivity. The next thing is the language barrier. In a context of India, there are about 18 official languages. So how does a farmer kind of interact with a mobile app which is in let's say English language? So the user interface has to be pretty easy to digest, and maybe if there is a local language support, that's another thought process that we got. And in fact, using Google Translator, we have built one Krishi web application wherein you can see the app in the regional languages. The demos follows in the next slides, of course. So again, the other problem is there is no off-the-shelf and affordable solution in the Indian context. So that's why we thought, okay, why can't we offer a solution, at least start offering a solution using these open source technologies to provide this part irrigation and remote surveillance, typically using the camera feed and showing it to the farmer via the mobile app. The next thing is, for example, like I mentioned, weather information and soil moisture data can be shared to the farmer. For example, also the pest bird control is another thing. The guys are the developers community are building these drones, right? How about using the drone cameras for farming? Also pest bird control. So the next thing is we can also keep updating and providing periodic updates to the farmers about the weather, and keep engaging with the farmer on the decisions that he can take with the krishi-IoT mobile app in place in the farmer's hand. So that's the kind of overview of this krishi-IoT and introduction of it. Please go through the blog that we have created. It has pretty good documentation, I guess, and our thought process, and also it has whatever the projects that we have tried on and the priorities and our hands-on experience as well. Okay, with that, I'm going to the next slide. So this is the architecture in a nutshell. So starting with the devices layer, we built around in fact, for the Open IoT challenge, we could able to build only 4 devices. Weather, as it says, it provides the weather information like temperature and humidity, so on and so forth. For that, we have used DHT22 sensor. For switch is nothing but a relay control. There we have demonstrated using an electrical bulb, but it can handle any electrical motor as well, water pumping motor as well. Next sensor is the earth sensor, which detects the soil moisture. The fourth one is the eye, which is a camera connected to Raspberry Pi and streams the live video, or even one can take a image on demand. That means from the mobile app, one can trigger the app to take the image. So the next thing is on the gateway layer. We thought initially we wanted to build one gateway which doesn't have any of the capabilities, but it kind of aggregates the data coming from these devices. But after a while, we thought, why can't we use one of these devices as a gateway itself? So that's when we thought, okay, switch can be used as a gateway since it is always connected to the electrical pump motor. And in case of power outages, we can inform the farmer like there is a power outage. So for the communication, we have used MQTT protocol, and as you have seen, there are also some kind of priorities assigned to these modules. In the sense, P1 being the higher priority, P2 being the lower priority. So initial thought was we wanted to use this Kapua project, which is pretty cool, I believe. And going forward, it will have a lot of traction, by the way I see it, because it is kind of aggregating or going to be the open source IoT cloud platform offering at the moment. But right now it is at a 0.20, and we could not really build the entire krishi-IoT solution based on it. But we hope we'll do it in the future going forward. Hawkbit, if you guys are not aware, it is to update the software on the devices remotely. So that's what Hawkbit does. And Hono is another interesting project where it kind of provide multi-protocol connectivity. For example, if your device is talking MQTT, yeah, you can send the data to Hono. HTTP, you can send it to Hono. In future, they have a promise of providing co-op or lightweight machine-to-machine adapters. And Hono provides one nice interface. That means AMQP, using only AMQP backend application, one can listen to multiple protocol devices. So that's the beauty of Hono. So we experimented with Hono and Kapua, and our study and our information is kind of documented in the blog. Please go through it, and if you have any questions, please feel free to share to us. So the next thing, moving on to the application layer. So we have used Ionic framework, which internally uses Apache Cordova project. So that helps us building Android and iOS apps. In fact, we built Android app, and it is available in the Amazon App Store. Please go through the blog and try and install it, and please share the feedback. The project code is available in the GitHub. So again, it is MIT license. We can work together and make it happen. So yeah, there is another interesting thing that we used IBM Cloud Foundry. For example, in cases where one cannot install mobile app, we thought using IBM Cloud Foundry, we installed we provided a kind of a web application, which is almost alike of this mobile app, and it also has this cool feature of this language translation. So this is about the architecture in a nutshell, and also the overview and timeline, everything in one slide. So I'm going to the next slide, which is pretty much the demos. So yeah, the other project that I did not cover in the previous presentation was the Eclipse Verto. This Verto project we felt is pretty cool because we were able to create a video of about 6 minutes in which we were able to install the Verto plugin and create a device information model and build a web application which shows the sensor information like temperature and humidity. You can see it in the YouTube link provided over here. I hope these slides will be shared to you guys. So I'm not gonna do the live demo here. Please go through that, and if you have any comments, and of course these are available in the blog as well, like I was saying. And there is a mobile app demonstration, of course the web app demonstration. These videos are available in YouTube. Please check it out and let us know your feedback. Finally, going ahead, we don't want to really stop here. We thought this is a great opportunity that we have got to work for this challenge, and also we have got a lot of interest from other folks around here who are interested and kind of committed to work on this project. So people are joining us to really make this as a reality. So please share this word and feel free to contribute to it. This is again open source GitHub project. Please provide stars as well. That also helps us. Of course, last but not the least, if you can donate, that will be the awesome thing. So if you have any questions, yeah, please feel free to ask me now.
Thank you very much. So yes, we will be sharing the slides. So but I think anyone searching for krishi-IoT on YouTube should find the videos that you shared. There is a question from Tien. I think you mentioned that there's in the platform you actually access weather forecast information. Which platform do you use for that? Is the question.
Yeah. Okay. Okay. In the solution that we built for Open IoT challenge, we do not have any. We not integrated the external weather forecast service, but we thought Okay, in fact, I have a POC running with AccuWeather. AccuWeather has got APIs. ACCU Weather. AccuWeather is the API that that is the one that I am evaluating. There is another one called Weather Underground. So they do provide REST APIs. So one can integrate with that.
Okay, excellent. So I hope this answers Tian's question. So yeah, this is great to see that you guys don't plan on stopping there. And I hope there will be you will be sharing the news whenever you add new features, etc. to the platform. I don't think there's any more questions at this point, but we might be collecting more by the time Sébastien goes through his presentation. Sébastien is the next speaker, and yeah, I mean, there were really lots of cool solutions being built in the challenge. It really was super hard, actually, for the judges from all the judges to come up with the top 3, and quite frankly, it was actually quite easy to find the top one. No offense to you guys, to Tom and Siva, but the winning team this year did an amazing job. And so just like we've invited Tom and Siva, we've invited Sébastien to tell us all about their project. You'll see that IoT, I like to remind people that like connecting sensors just for the sake of like putting a GPS tracker on your dog will probably not make a difference. It starts by thinking about a real problem that you want to solve, and then maybe some sensors might be helpful. Connecting the sensors might be even more helpful, and I think that's essentially what Sébastien and his team has just built. So how about Sébastien, you tell us more about In Mood for Sleep. I keep mixing up the name, so welcome.
Okay, thank you. Do you listen to me? It's okay, the microphone?
Yep.
Okay, perfect. I am developer in France, working in a startup on the platform data. But I'm on the project of IoT project. For me, it's, as you said, solve a problem. If you're not a problem, it's like in a startup, you cannot build easily a product. And In Mood for Life project aims to help people with bipolar disorder, and I want to explain now why there is a problem with specifically this pathology, and why deeply there. Okay, I switch on the slide.
There you go.
The correction of build a product is based on my personal experience. Many tools exist for improve a therapeutic approach, but in fact, they are difficult to set up without a professional supervision, and many tools are built for adults and not for children. However, we have to react because this disease has a strong destruction power. When we are talking about bipolarity, we are talking about suicide, we are talking about internments, and other consequences are in the daily life of patients, family, and friends around them. But there is a side shadow and a side light. Well-treated people with bipolar disorders have a fantastic power of creativity. They don't see the world like us, and they contribute to expand the limit of the possible. Look at just these faces. Everybody knows them. Everybody. Globally, React is a major emergency because recent researches prove that more than 115 million persons are concerned by this pathology in the world. According to the World Health Organization, bipolar disorders is the 5th cause of handicap in the world. This is the reality. The root cause is a genetic vulnerability present between 5 to 10% of the worldwide population. So it will not stop. It is like that. We have to deal with it. Among other factors, regulating awake and sleep phases are deeply impacted. Clock desynchronization are often behind a phase of shift, mania, or depression. Teens with bipolar disorders are particularly exposed to clock desynchronizations due to the strong brain modification during this period. Sleep monitoring is also a powerful tool to improve the therapeutic approach. In reality, medical sleep monitoring cannot be used daily at home. It looks like that. I ask myself if somebody with sensors on him can really sleep or not. But this is the reality. And even if this device could be connected and wearable, it doesn't change anything because practitioner will not analyze manually every day data generated by sleep trackers at home. We are talking about 4 million data points per night in a minimal form. Only data analytics automation creates value, connect a device, simplify only interaction. It is important too, but the value creation is based on analytics. Integrate analytics model into a psycho-education application for patients and psychiatrists solve the problem. This is the aim of In the Mood for Life, solve this problem. And just a few years ago, develop this type of device at a very significant cost. Today, open hardware and software have completely changed the game. High-quality base bricks are available and IoT ecosystems are growing. Developers, hackers can be focused on the most important thing, the product. It was completely our guideline during this challenge. Firstly, we had to choose a sensor. We selected a bedded sleep tracker because the sensor is non-intrusive and gives the ability to read on the device via Bluetooth from the ballistocardiographic sensor. With a ballistocardiographic sensor, you can extract 3 physical metrics: the respiratory rate, the heart rate, and the agitation level. The data store and the analytics application is deployed locally on a Raspberry Pi in order to record and analyze data automatically without any user interaction. In this case, privacy is also respected too. By default, no cloud connection is needed. Sleep tracker data are sensitive data for me. The data acquisition pipeline is built on Eclipse Vertex project. This is the nervous system of our device. With one critical task, collect 115 data points per second from the bedded sensor and inject them into a time series data store, WAP10, in a smooth asynchronous way. At this level, a standard database does not fit to the needs. It's not efficient. Only a time series database can deal with this level. Vertex exposes also an API and a progressive web app for user interaction. For the moment, the user information we develop is a Bluetooth pairing with the device, and we are thinking about a patient dashboard. The data analytics is done with Warp Script, a data manipulation language dedicated to time series analysis, directly executed on the Pi, on the platform embedded. The first step is to evaluate the signal quality. You cannot make a good analysis if you have not a good signal. The signal decomposition. The signal decomposition is based with statistic tools. We extract three metrics from the raw signal: the respiratory rate, the heart rate, and the agitation level, minute by minute. The second step, when the night is ended, we can analyze the sleep architecture and extract, once again, three metrics for the night: the time needed for falling asleep, the time awake during the night, and the quality of the REM sleep, also known as paradoxal sleep. When you look at the evolution of these metrics on a period of 50 days, you have an overall trend of the sleep quality and the potential impact with mood disorder. This model have to be medically confirmed and give us hope for adaptive treatment prior and major crisis phases. The chart you see on the slide is the chart of a sensor already in a bed for bipolar teens. And we have seen recently a mixed state. It is a depression plus maniac state. And the metric was concording with the observation of the behavior of the child. So we have to work to medically confirm that, but this is really interesting. Like other teams, we are eternally grateful this technology provides for all developers around the world. Without open source software, today this project will be only an idea between other ideas. And we have now to continue the movement. The IoT challenge was the bootstrap for InMove for Life. We will start the medical validation, bench the sleep decomposition with medical references devices in order to validate a confidence factor of the physical metrics collected. We already work with psychiatrists in order to be able to measure patients' benefits. And we will integrate other open source technology like Orbit and Ono in order to build the device, to update the device remotely with only one obsession: security and privacy by design. And of course, we don't have to break it, so we have to use a well-designed solution. I want to thank Benjamin and Roxanne and the World Eclipse Foundation for their work.
Well, and thank you for what you've built. I think this will help many people. Am I having issues with the connection? I may have had an issue with my connection, but I think I'm back. Yeah, one question I have, and I hope others will jump in the conversation, including maybe actually your colleagues who also participated in the challenge. I mean, by colleague, I mean Tom and Siva. One question I have is around, I mean, you mentioned that security and privacy is, of course, important. However, I'm wondering whether you've been considering, or if you're already considering, building some kind of open platform for the data itself. Like, would it make sense to have anonymized data for the sleep patterns of people, including healthy people or people with mood disorder, and try to share this for researchers and for maybe people like you who might be able to figure out new ways to correlate the information. Are you aware of such platforms already, or are you already considering opening up the data in a way?
This is a difficult question, because when we are talking about privacy and medical data, you have some state regulation, and you have to deal with it. France is different than the United States, which is different than Germany, which is different than every country have a specific rules. So the first thing is to be anonymized by default. The anonymization is done in a sign-up process. So for that, we build a cryptographic solution with an end-to-end cryptographic between the patient and the psychiatrist and the doctors. The platform is have to be completely neutral in this goal. After, the second problem with the raw data is related to the life activity. Sometimes you have private activity during the night, and this activity is not related to sleep tracker. And the sleep tracker have to split the activity of sleeping and not sleeping in the bed in order to expose only the purpose of the data analytics needs.
Right.
And after, the power and the control have to keep in the patient locally on the application connected to the Raspberry Pi. And if you want to be deconnected, you have to be deconnected without any consequences.
Right.
This is the way I see the privacy in medical use. After, for mass treatment, they have to give a consentment for authorized treatment for research. This already exists. This is not a problem. The only problem is who have access to this data set, and I will give the right access to the right person without the privacy correctly chained.
Yeah, so there's a whole world of issues there, but at least you've been working on the foundation. I'm actually curious, like this whole idea of working with sleep patterns, is this something that you've already started thinking and working on before the challenge, or you've essentially built everything just in the course of the few months that the challenge lasted?
In fact, both. I am personally impacted by this pathology, and I read research papers since few years. But I had in my mind, okay, maybe one day I will build something, but I didn't exactly how and what to build.
Yes.
And when I see the Eclipse Open IoT challenge, I say to myself, gotcha, I have to take the opportunity and to try something. It is the first aim. So I did not have a plan before starting, and all became clear very quickly. When I see the metrics, I see the data, and I see what I can do with it.
I realized that, well, and I apologize if I missed that, but for people interested in your project, is there some code available for people to have a look at? Like, is there a GitHub repo where people can look? And again, I apologize if I missed it, but if in any case, can you maybe remind people where to look?
All the code is integrally available on GitHub. And I put on GitHub only things that are validated in the sleep architecture. So the research work is not directly on GitHub, and I put when the work have a level of maturity in order to reuse in good condition. Why I do that? Because I have request from a developer in the United States working on diabetes, and he's okay. It's frustrating for me. I have to evaluate the benefits with the sleep patterns for children with artificial pancreas. So they had to take a good base without bugs and any problems.
Right. And just curious, did you get any contributions already? People looking at your code and proposing patches?
Not yet.
Okay.
Not yet. My code have a small problem right now. There is no comments.
Okay.
It's very bad, I know, but I have to make some efforts for that.
Yeah.
And I put a documentation, put comments, and over classical.
So maybe people interested.
Project.
Yeah, people interested in contributing may want to contribute documentation.
Everybody are welcome.
Sure. Okay, awesome. I would like to quickly go back to Tom, actually, for a question that we had earlier on. So the question is from York around, York is asking, how do you take a consumption of electrical or fossil energy into account? I guess, like, in terms of building the dashboard and building up the metrics, how do you make the difference between what comes from where and what's the equivalent in terms of fossil energy? Can you elaborate on that?
Sure. Right now, we're just focused on heat. The basic of the project was to measure heat loss in the building, and so we're not really looking at gas consumption or energy consumption from a physical fossil point of view at this point. We're just looking at it from an empirical point of view of whether the house is heating and cooling, and then how much BTUs that the type of energy, in my particular case is gas, how much BTUs that would use per hour, and then that translates into carbon output.
All right, that makes sense. So I hope your group was still around, and I'm pretty sure that answers the question. So I think we're both running out of time and questions. Any final comments from you guys? So as a reminder for people watching and who might be interested in participating to future editions of the challenge, I hope we'll have something lined up for some time end of this year. As a reminder, the winners went away with very nice prizes. I believe there are nice prizes. Gift certificates to buy hardware, as well as some cool hardware kits being provided by. I realized I actually forgot to mention one of our sponsors earlier on, which is MicroEJ, and they provided some hardware that allow for people to build Java embedded solutions. Bit Reactive provided a license to their Reactive Blocks tool, and Bosch, Eurotech, Red Hat helped provide also the money that we need to run the challenge. So very quick question, and you don't have to go into details, but what will you be using your prizes for, guys? So Tom.
My plan to continue to move the project forward, I'm going to be looking at different types of sensors and different platforms for commercialization. Right now, I'm not really sure what the final product or idea is going to be based on, but the money is going to help me, and the software applications and licenses are going to help me move it forward for sure.
Awesome, that's what we want to see. Siva, any thoughts on what you're going to... I know that and we still actually need to work with you on sending the gifts over to India. It's not always easy for us to source the gifts, but any ideas on what you're going to use the gifts for and the prizes? I think you might be on mute, Siva. So how about you, Sebastian?
Okay.
Siva, are you still there? Or
Yes, Sebas. Yes, Benjamin, I'm here. Can you hear me?
yes. So very quickly, what do you plan on using your price for?
Yeah, first I would like to look at the devices that I'm gonna get.
Yeah.
And whatever the POCs that we have built are really using a Raspberry Pi and ESP8266. Based on the kits that we get, we'll see and how to take it to the next level. Right now we are having it. The pieces are different hardware pieces are hanging around and they're connected via breadboard connections. But going forward, we want to make it a PCB layout.
Yes.
That's the plan, and let's see. Hopefully, we'll surprise you.
Okay, cool, awesome. And last but not least, Sebastian, or what will you do with the price?
The Raspberry Pi I used have a design problem. When you cut off electricity, you can break the device by written on the SD card, and on a data acquisition process, it is not acceptable in production. For test, it's okay, but for production, it's not possible. So I plan to use the compute module free of the Raspberry Pi Foundation and build a small board with only the electronic element necessary, the Bluetooth head, the Wi-Fi, and the SD card, because I don't need HDMI and not need jack, and adds lithium battery in order to cut off safely the power when the device is not under alimentation.
Yeah. Okay. Cool. So that's really great. Thanks to all of you guys for spending the time to talk about your projects. For those of you watching, as a reminder, well, feel free to reach out anytime. You can comment on YouTube, and we'll make sure to direct your questions to the participants if you have any questions. And also stay tuned for Open IoT Challenge 4. Like I said, this will come later this year. So yeah, to everyone who watched, to everyone who participated to the challenge, to all the winners, you are all awesome, and especially you guys winning. We, like, all the judges were mind blown by what you've built, and I really mean it. And I think Roxanne will join me in saying that as well. So we'll be back for Virtual IoT next week, talking about smart home and Open Hub. So we'll be back at the regular time slot, I believe, and that will be on next Thursday.
Yeah, it'll be the 19th.
19th. So that will be on Wednesday then.
Yeah.
There you go. So thank you. That was slightly longer than a typical virtual IoT, but this was packed with very cool content, I believe. We'll be posting the links to the slides as well. So you have all the links, all the videos, etc. And thank you again, Tom, Siva, Sebastian. See you around. Thank you, Roxanne, as well. Bye-bye.
Thanks. Bye.
Take care, everyone.
Thank you.
Bye-bye. Thank you.